All right, so I mean, we talked a little bit earlier about, what actuaries do. Okay, what does an actuary do? It's like a really quick answer. Anyone remember? What does an actuary do? You can put it in the chat. Oh, Carl, go ahead.
Okay, then from what I heard, actually, they transform, they take purpose problem and transform it to mathematics. They transform purpose problem in mathematics in a mathematical way and try to predict the future with those data.
Nice. There you go.
Yes.
Exactly. Yeah. And Tara's wrote it as well in the chat as well. Yeah, exactly. We predict the future with math. And we're doing that, Nancy mentioned managing risk. We're doing that because we're trying to manage the risk, right? And we use that past to predict the future. So if you think about it, if I'm trying to predict the future with math, and we already talked about how we take a data set, we push that into the future, really, it's all about predictive modeling, isn't it? It's all about predictive modeling. And so even if you look at our actuarial methods, which we won't go into today, but all of the actuarial methods, we need data, first of all. And how do we get data? Well, we have to program, right? So we need data. And once we have the data, we need to be able to massage it and move it around and adjust it and mess with it, right? So that we can filter it and get it to the point and at the level that we need for our analysis. And then even more important, now that we have more capabilities, so we have computers that work faster, we have computers that work harder, they have more memory, we have servers that can hold mass amounts of data, we have better capabilities of grabbing that data and bringing it into our analysis, even at a granular level, which is what granular means, is at the lowest level, where every single row is a transaction or a claim instead of being all rolled up. Okay. So we have the capability of doing this. We have the storage capabilities of all these servers, and now, server farms where clouds live, right? Where we call the cloud. We even have the capabilities of all. Now that we have all this, it's almost like the everything is like greased up so that we can deal with this data faster and better and faster and faster and better. And what that leads to is innovation, right? That leads us to the capability of taking that data and doing a better and better job of predicting the future. Now, these actuarial methods that we've been using for years and years and years with our calculators and on pieces of paper, right, have been great. And we still continue to use them. They're really good for estimation purposes. But if we can do it better, if we can separate the policyholders into more homogeneous, credible groupings and make those predictions better, then we win. And if we do it better than our competitors, we will experience what's called favorable selection, as opposed to what's called adverse selection. I'm sure many of you who have studied actuarial science so far recognize those words, right? Favorable selection means you're winning against your competitors. Adverse selection means you're losing against your competitors. And when in the science of predicting the future, which is exactly what we're doing, the better you can do it, the more you're going to win. And so that becomes a very tricky thing, because if you think about selling insurance, what we're actually selling, and even with banking and investments, what we're actually selling with insurance is a promise that we will indemnify you, we'll cover your losses, we'll make everything whole in that future if something happens. And so it's not like a candy bar where I already know the costs ahead of time, right? It's not like a candy bar where I have the chocolate and the nuts and the distribution and how much my workers are going to be paid. I don't know any of that. I don't know my losses. I don't know my expenses. They're all in the future. I have to predict it, right? So Keithon mentioned programming is important to be able to deal with big data and use automation to tell the data what to do. Exactly, right? Yep, exactly. We need to have that capability of being able to use that data to make those predictions. And with the advent of all of these computing capabilities, we now have more and more capabilities of doing predictive modeling. Okay. And you're going to see that, all of you will see that more and more and more in your studies and in on the job when you do become on the job, when you do get actuarial jobs, is you're going to see generalized linear models and tree-based methods and unsupervised learning, and you're going to start seeing all of these predictive modeling capabilities, heavier and heavier statistical capabilities. But what they do is particularly generalized linear models, is they allow us to better build those class plans, to better build that algorithm, to better predict the reserves on a more accurate and a longer term scale. And so definitely we need to be able to program so that we can do all of those things. Okay. And so if you think about it, like I said, candy bars, we already know the costs and we already know how much profit we want. So on day one, before we even sell the candy bar, we already know how much to sell it for. Well, with insurance, we're selling those promises for future costs. Okay. We're selling those. How do we figure out how much it's going to cost, so that we can figure out how much to sell it for? And at the same time, how do we know how much to sell it for if we're also competing with all of these other companies, right? I'm competing, if I'm in personal lines and I'm selling auto and home insurance, I'm competing with Geico, and Geico is like advertising everywhere, save 15% or more on your car insurance, right? And so it's not just the math. There's so much more to it. And as an actuary, you think about a bike, right? A bicycle tire, okay? An actuary is like the middle of the tire, and all of your business partners are all the spokes going out. As an actuary, you need to understand underwriting, you need to understand claims, you need to understand legal, you need to understand the product side of the house, how agents work, what the brokers need, what the market is doing. It's like you need to be a Jack and Jill of all trades, right? You need to be able to understand all of that. So super exciting stuff. Okay. And so somehow we need to be able to predict this. We already talked about this. We're going to take our historical data. We're going to adjust that data to some future time period. In other words, the future time period of when the policyholders are going to be buying the policies, right? Because we're trying to predict how much they should pay, right? We're trying to predict how much they should pay now for expected losses that we don't know about yet, that haven't happened yet. Okay. And we're going to use industry benchmarks, assumptions, some of the trends and patterns from our historical data to come up with this adjusted data to predict these future losses. Okay. And then I'm going to apply statistical techniques and predictive modeling and actuarial techniques to that future adjusted data set. Okay. Are there any questions on that? That is a very important concept when it comes to all things actuarial.
My question I have is, how much dependence do actuaries have on using historical data? Do you excessively depend on using historical data?
We do, because honestly, that's our only choice, right? If we would prefer to have real, future data, but we would need a time machine for that. Right. So our only choices are to use the historical data and adjust it and pretend like it's the future data set, like a proxy data set, or not have that and come up with just completely subjective assumptions, right? Industry benchmarks. Does that make sense, Daniel?
Yeah.
Yep, good question. Chris?
Just a quick question. As you adjust this data, are we massaging it, say, with logarithms and square root and what have you? And do you add a randomness component?
Very, very good question. So what we end up doing by massaging the data, again, this a lot of these questions are a semester long answer, right? But what we're doing is we are going to be taking that historical data and we're going to pretend like it's in the future. So we're going to look at trends. We're going to do trending, which sometimes are exponential, right? And sometimes, we're going to pick selection of trends. Most of the time, though, they're going to just be a regular, interest rate type trend. If we're going to trend them into the future, we're going to look at rate changes over time. We're going to look at changes in our loss environment and trend and push that in the future. We're going to do what's called ultimate. We're going to set our reserves and our losses at ultimate, which means when things are all said and done, how much did we pay for a policy, for a claim, excuse me, right? And so essentially we're not maximize, but we're pushing everything into its final state, and then we're going to adjust all of those costs for inflationary forces and loss changes and push that into the future. Now, a lot of times that's done on from using actuarial methods, and it still is. But we're also we've been introducing more and more predictive modeling and even stochastic modeling, which allows us to, build ranges around it, just like you're insinuating, Chris, right? And so we can make decisions on the variance, we can make decisions on the randomness of our selections, which will allow us to be able to say, rather than it being a point estimate, like the actuary comes in and says, the answer is 4,563,243.73 cents, right? Instead of it being that, we can come in and say, I ethically feel that you can make a decision between this and this, and it's a good estimate. So we walk in with confidence intervals oftentimes. Does that make sense, Chris?
Perfect. Thank you.
Yeah, good question. Samuel says, do you guys consider ethical issues with the data? Oh yeah, such as building a model based on variables like gender, race, etc. Very good question, Samuel. There is a lot of work being done from JSEED and from the Casualty Actuarial Society on, Malika Bender actually is leading a team on systemic bias, right? Identifying systemic bias in our historical data, because Samuel, you are spot on. If we are taking historical data, and if we are using that data to predict the future, aren't we just passing along the systemic bias that exists in the data? Yes, we are. And so that's why there's all kinds of efforts being done right now to say, from an actuarial standpoint, what sort of assumptions can we bring into our actuarial adjustments to avoid that systemic bias that exists in the data? So examples of that might be, should we really consider credit score, which is an incredibly statistically significant tie, has an incredibly statistically significant tie to expected losses. The lower your credit score, the higher your losses. The higher your credit score, the lower your losses. It is statistically almost 100% correlated. It's amazing. But due to systemic bias in the history of the United States in particular, right? Credit score is sometimes considered a proxy for race. And so it is unethical in certain circumstances for certain lines of business and certain products, right? And so how do we use the benefits of, of what's going in, what is driving the signal with credit score to help us predict those expected losses? Because those are true, those are actually happening, and we want to price accordingly. But how do we do that in a more ethical way? Right? And these are the kind of questions that are being asked right now. Another thing is certain states, you mentioned gender as well. Certain states have, their departments of insurance and their legislatures have decided against, you're not allowed to use gender. You're not allowed to use this. You're not allowed to use that. No states, I mean, obviously none of us are going to use race as a, on the P&C side. I understand, from a life and health, it's a little more gray area there, right? Because your race does actually have direct relations to your expected losses. And so that's a very touchy and you have to be very careful with that. But interestingly enough, states like Montana that say, no, you can't use gender. If you take auto insurance, for example, women are statistically better drivers. They're much safer and they have lower expected losses. And so by Montana saying, no, you can't use gender, right? That is actually, it actually ended up having the opposite effect, right? It actually ended up having it being unfair for women in that particular instance. And so we have to weigh these different things, right? That's what's going on there. Good question, Samuel. All right, any other questions on this data adjustment? Very, very cool stuff going on right now. In fact, I suggest for each of you to look up on the CAS website, casact.org. In fact, let me just put it in the chat. And they've been released already 4 papers recently on how race and removing systemic bias in our actuarial work. And that's definitely worth. There's going to be another paper that's being finished up right now that's going to be released soon. But 4 of them were released about a month ago. And so I would highly suggest taking the time and reading through those papers because they're very, very cool stuff. And it's just the tip of the iceberg. There's a lot more work to do, but at least we're having those conversations now, right? So it's good stuff. Awesome. All right. So this future data set with all these predictive modeling and all these different things going on, it's used in rate making like we talked about and reserving. But actuaries are also involved. Again, anytime anyone needs to predict the future with math, actuaries are involved. So we are also helping out with planning, business planning. We're helping out with book management. We're helping out with the underwriters. We're helping out with investment strategy, claim analytics, more and more and more and more and more. We're used all over the companies. To do all kinds of different things. Anytime someone needs to predict the future with math, an actuary is brought in, okay? And so if you think about that, we have to push that data into the future. How are we doing that? Well, that data lives in a server, okay? Does anyone willing to explain what a server is? Does anyone know what a server is? Not like a waiter at a restaurant, but like a like a server, a computer server. Chris, would you be willing to explain it real quick?
Yes, Stan. Servers, it's really just at the most basic level, a computer. And you can access it usually interactively over the web or in the intranet within the organization at a university or whatnot. And it allows you to query information, let's say from Access, as you have on the screen here, or Excel and different databases using SQL language.
Good, awesome. Yeah, so it's just it's a computer, but the thing is, you have your laptop or your desktop that you're looking at right now. Okay. Within that, thanks, Chris. And within that laptop or desktop, you have a hard drive. That hard drive is going to be your storage, right? It's storing all your files. And I'm sure some of you, every once in a while, you're running out of space and you have to delete some stuff because you took too many pictures of your desserts at restaurants, right? And so you have to you have to delete some stuff. But you also have what's called RAM or memory in your laptop as well. And that's like the thinking juice for your computer. Okay. And that limits you. So if you try to run some big model, right, some really big model on your laptop, it's going to be all slow and it's not going to work and you can't do anything else. Just like Chris said, a server is an external computer. But the thing is, this computer is not user-friendly, like at all, because it's not built to be user-friendly. It needs the space. The computer, this server has a whole bunch of space and a whole bunch of RAM. And so you use it to save all your stuff and you're going to use it to run things. So I might remote out to the server and run my big old model on the server using this server's brain juice, right? Using its memory. And I'm gonna make things less magical for you for a second. In North Carolina and Washington State and other places like that, they have these big farms, these big, huge warehouses with lots and lots of servers in them. And those servers are called clouds. That's what the cloud is. It's not some magical thing. It's actually just you're paying Google or Amazon money to store your pictures of your desserts on a server in a warehouse in North Carolina. That's basically what it is, right? And so the thing with these servers, whether it's on the cloud or whether it's a server that's at your building, you need to be able to access the data from the server because that's where all your actuarial data is going to be living. It's going to be living on that server, okay? And so most servers they speak in SQL language, SQL. It stands for Structured Query Language, okay? Most servers that actuaries are going to deal with are probably Oracle servers, and they speak SQL. Some of them might be, they might be speaking Linux. If you have an older type server, that's another different language, Linux. But the one that you're going to probably using the most often is SQL. We'll talk a little bit. I'll introduce you to SQL in a few minutes. But SQL is going to be a pretty basic language. You can actually go on. Oh, you know what? Sorry, earlier I put thanks for putting the link in there, Morgan. I put the link just to you. So you can actually go to codecademy.com, okay? If you go to codecademy.com, and I put this in the slides as well. Is it .org? I don't know, it might be org or com, but Codecademy has an introductory course on SQL. Just do all the free stuff. Don't pay anything. Sorry, Codecademy, but don't pay anything. Just do all the free stuff. They have a really good introduction to SQL. And I think that would definitely be worth going through and playing around with, particularly when you're getting ready to update your resume and things like that. Okay. But that's exactly what we do. So in order to adjust this historical data, I'm going to use SQL language to pull the data, to filter it, to massage it, to get it in the format that I want. And then I'm going to use that data to do my analysis. Okay. If I'm doing a smaller data set and it's ad hoc, which means it's not a big process. It's something like a business partner walked up to me and said, hey, how many automobiles do we have in territory 3 of the state of Montana? Right? Something ad hoc, which means like I need to figure this out right now. It's not planned. It's just something I'm trying to do. I'm going to use Excel. Okay, I'm going to tend to use Excel to do that. I'm also going to use Excel to show some of my analysis to my business partners. It's a very good tool to kind of organize and work with stuff. If it's a medium data set and it's a repeated process, in the past, we would have used Access. Now, I personally hate Access. It's disgusting. It's gross. No one should ever use it. Okay.
I'm laughing. I'm sorry, Dan. I'm laughing because I just taught a class in Access.
On Access.
Yeah.
Oh, I'm so sorry.
No.
I'm so sorry you have to do that. No, I mean, and Access is definitely with the introduction to Python and R, which is these two right here. Access is becoming less and less important. But in fact, I spend quite a bit of my time moving things from Access, Chris, into other things.
I know.
So.
I know. I'm already outdated.
But yeah, what you're going to end up seeing in the future, everyone, is R in particular. Some folks use Python, and if companies are big enough and they can afford it, they'll use SAS. SAS is very expensive. That's the only reason why a lot of companies are moving away from it. Python is also costs a bit, but R is kind of where more actuaries are headed, at least on the property and casualty side of things. And the reason why is it's crowdsourced, which means that we have PhD students all over the world inventing new functions that we can take advantage of if we want to do something cool. Okay. But it's also very statistical based. It's already has built into it, different distributions we might use. If I want to use a Weibull, it's already there. It's ready for me to use. If I want to use gamma or Poisson, it's already there, right? And so, for example, R, if I want to do a generalized linear model, if I want to do a GLM, I can do it in one line of code. Whereas, other programs, it's a lot of work, right? But with R, I can do it in one line of code. Super, super easy, okay? So once again, I'm going to take historical data that's living on the servers. I'm going to use SQL to get the data. I'm not using SQL to do any modeling or any analysis. I'm just getting the data with SQL. And then I'm either going to use that data to do analysis in Excel or Access, or what's becoming more common, R or Python. Okay. Any questions on that? So you can see where this is going, right? If I'm pulling large amounts of data, I'm making it a little bit smaller using SQL, and I pull it into R, not only can I do my regular actuarial analysis, but now I can also do some deeper statistical stochastic analysis and predictive modeling, and I can do generalized linear models in one line of code, and I can do tree-based method analysis, GBMs, and I can do all kinds of really cool stuff because R is built to do it. And it's really easy to do, okay? Not only that, which is really cool, is you can build the SQL code in R, so you can do it all in one program. So pretty cool stuff. Any questions on this process here? Reminds me of grad school, yeah, for sure. All right. Cool, so let's talk about Excel for a second. I put a bunch of slides in here to help you out, but I'm going to, rather than showing you slides, I'm going to, that's weird, my taskbar disappeared. Okay, here we go. I'm going to just open an Excel book right now and let you see it, okay? How many of you, I don't know how to, put a thumbs up if you've worked in Excel before or extensively. Okay. All right, keep going. This will just give me an idea of how deep I need to go. Okay, cool. It looks like about half the folks, right, who have been in Excel before. 2 classes taught in Excel. There you go. All right. So Excel is the reason why we use Excel so much is because it's just perfect for playing around with data, right? So all kinds of cool stuff you can do. You can pull it in here. The restrictions of Excel, those who gave a thumbs up, what do you think I am restricted here in Excel? Some of you may have already experienced it. What are some things I can't do in Excel if I'm working with data?
Sorry, Dan. Yeah, sorry to interrupt. Databases are a little, you can't deal with large files too comfortably.
Yep, exactly. Yeah, it's real slow and yeah, exactly. Okay. And so Excel only has a certain number of rows. And in fact, if you use all those rows, it still gets real mad. In fact, my Excel, often if I'm using anything above 200,000 or 300,000, it starts going a little slow, right? Starts getting a little mad. And so Excel, like I said in the slide previously, it's going to be really good for smaller data sets, ad hoc, real quick analysis. And whenever you're done with all your stuff and you want to just do a summary explanation and give that to someone in an email, Excel's really good caveat, not caveat, a good way to do that. Okay. And so it looks like many of you already know Excel. You know that you can put functions in here. Obviously, the actuary's favorite function is the VLOOKUP. So hopefully all of you can learn that. If you don't, I would highly suggest you do. I put some slides in here with VLOOKUP information on that as well. Okay. So I definitely would take the time to get to know Excel. The other thing in Excel that is going to be an actuary's best friend is the pivot table. Okay. The pivot table. What the pivot table does is it allows you to play around with your data in a very easy way. So let's say, for instance, I have age and state and premium. Okay. So I should have prepared this ahead of time, but it's okay. 52 and I don't know, 45 and 32 and 20, 12. No, there shouldn't be anyone named that's 12 in the database. That's ridiculous. All right. And then 50. California, Connecticut, Massachusetts, and let's see, Florida. Okay. Premium, they're in California, so it's obviously really, really expensive. Okay. And then we got Connecticut, which is medium expensive. 3,500. I'm just making up data here. All right, 4,000, and then $50 because they're in northern Florida. All right, so if I just have some data here, okay. The cool thing about a pivot table is I can take that information, and again, I put information in the slides for you to play around with these later. I also believe Codecademy has an introduction to Excel as well. If not, you can find all kinds of free stuff online. Don't ever pay for these things, okay? There's plenty of free stuff online. So you can find some free stuff online. So if I want to look at this data, I can do all kinds of really cool stuff. So let's say that by age, I want to know the premiums. Well, here's the summation of my premiums by age. And let's say that if I want it by state, okay, I can drag this over here. By state, I know that California has this much. Connecticut, it's summed up the 2 Connecticut's for me. You see that? 6,500. Okay, and summed it all up for me. I have a grand total. I can do all kinds of cool stuff. There's charts. I can build charts. I can build tables. So Excel, I would highly suggest getting very comfortable with Excel. And if you have to pick 2 things in Excel to be comfortable with, it is the VLOOKUP and the pivot table. I would get comfortable with those 2 things. Okay. Chris, do you have anything to add to that? Very high level?
Just one small thing. Pivot charts and graphing are so neat because you can actually change, in real time, the charts for the execs.
Yeah, so cool. Yep. So there's lots of all kinds of different stuff. We had all these different charts and all of these here, pivot charts. That's what Chris is talking about. So very, very cool stuff. Obviously, Chris taught a whole semester on Excel, right? So there's plenty that you can do with it. So I would highly suggest playing around with it, getting used to it. Okay. Any questions on Excel? Samuel asked, would you say Power BI is important that Excel as an actuary? Because you talked about pivot table being very important, and I think Power BI does. Yep. So Power BI is going to give you the capability of, so sorry, for those that don't know what Power BI is, it is just a really, really more powerful pivot table that allows you to deal with a lot more data. Okay. And so, yes, Samuel, it's going to be very important. However, there's a little caveat that goes with this. If you're getting to the point where you're trying to make an Excel file behave a certain way because it's trying to massage a lot of data, at that point, you should just use R. Does that make sense, Samuel? Yeah. Okay. Nice. How about VBA and Excel? I was actually going there next, Nancy. Yep. Is integrating VBA code in a data set and asset? Yes. So to answer both of you, yes, absolutely. So it's almost like you have to think about a level of what you're doing. What kind of project are you working on? And so if it's going to be basic and it's going to be ad hoc, Excel is really good. If you need to do anything, and my rule of thumb is if I have to repeat a process in Excel more than 3 times, I'm going to write VBA because I'm lazy. Right? I don't want to have to go copy paste, copy paste, copy paste, copy paste. Like I don't want to do that over and over again. So I'm going to go ahead and write some VBA code. And what VBA stands for is Visual Basic, or what's A stand for? Applications, right? So Visual Basic for applications. And what it basically means is within Excel and any Microsoft product, I don't know if you knew that, VBA works for Outlook. I can write VBA in Outlook. I can write VBA for PowerPoint, for Word. So any Microsoft product, you can write code that will run behind the scenes for you. Okay, and that's what VBA is. When you get an Excel file, you need to introduce this developer tab. The way you do that is you go to the file and you're going to go to, where are you? Huh. Options is supposed to, oh, down here. Okay, you're going to go to options. That's where they moved it. Options. Okay. And then in your customized ribbon area, and all this is in the slides, by the way, you don't have to remember this. Okay. But in the customized ribbon area, you can click on this developer tab right here, and it'll show the developer tab in your ribbon. So up here in the developer tab, this is where you're going to get to your Visual Basic right here. Now I want to look at my macros. Right now, I don't have any macros in this particular Excel file, but this is kind of where you're working around with your code. The easiest way that you are going to write VBA code isn't necessarily going to be from scratch. Now, if you want to be a total rock star and do all kinds of really cool stuff, you can learn VBA as an actuary. However, remember we talked about we're going to use Excel for ad hoc analysis and for some regular reports with smaller amounts of data. So spending the time to really be amazing at VBA is not necessarily going to make you a better asset necessarily in the actuarial world. And the reason why is because if it's something that I need to just repeat over and over again, I can just record the macro and that'll actually write the VBA code for me. So let's say, for instance, I needed to copy and paste this table over here, over and over again. Then I could hit record macro. I can name it table move, something like that. Okay. I can even put a keyboard shortcut, maybe Control Q. Okay. Oh, I can't do that because I have to do this underscore. All right. Okay. And it's going to record right now. It's recording what I'm doing. And I'm going to copy and paste this here. And then that will be the end of my macro. So what it ended up doing is it recorded and wrote the code for me. This is the VBA code of what I just did. I selected the range L2 through N7. I copied it. Then I selected the range P2 and then I pasted it. That's what it did. So if I, for example, want to do that without actually doing it, I can now, because remember I made a keyboard shortcut, I can now do Control Q and it just did it. Pretty cool, right? And so you can imagine how important that's going to be. Let's say, for instance, that I wanted to do that for numerous sheets. Let's say I had a different state for every sheet. And let's say that I had a table in the same spot on each sheet. Was that L2? Okay. With different information. Okay. I can actually go to this sheet and hit Control Q and it'll do it. Because I wrote the mat. That's what VBA does. It's behind the scenes and it allows you to run code whenever you need to run it. Pretty cool, right? And so you can imagine how useful VBA is going to be. But again, as an actuary, I'm using Excel more on the fly. I'm using it more on an ad hoc basis. So yes, it's very important to understand VBA. And yes, it's very important to understand how to troubleshoot it and update it. But maybe as an actuary, it's not as important to know how to build it from scratch and do really crazy complicated things. Okay. If you're going to spend your time learning a language, you should spend your time learning SQL and R. That's what you should spend your time doing. Okay. Because, and you know, this makes kind of logical sense, right? If your Excel files are getting more and more complicated, it's time to start thinking, maybe I should do this in R, or maybe I should do this in Python. Does that make sense? So that's kind of the idea behind it. And to Chris's point, at that point, you should start saying, maybe I should do this in Access, right? And so I wouldn't say that personally, but but that's, you know, that's the point. Excel is not built to do crazy, you know, ridiculously complicated things. It's built to be able to play around with the data with pivot tables, and it's built to do some, you know, investigative analysis on your data, and it's built to build really pretty displays for your business partners, right? To summarize your results. So good stuff. All right, any questions on Excel or VBA? All right, so I am feeling a lull. I'm feeling that people are getting a little tired of hearing my voice. So let's actually go ahead and take a 5-minute break. I know that's not a very long break, but go ahead and take a 5-minute break. Everyone go to the bathroom if you need to, get a drink of water, do some jumping jacks, maybe a few push-ups, and then we'll start back up at 7:36 my time. So what would that be, 6:36 for other people? And okay. So well, I'll see you in about 5 minutes and we'll start back up. right, we're gonna go ahead and get started in about 1 minute. We'll give it 1 more minute for folks to get back. Okay, everyone hear me okay? Give me a thumbs up if you can hear me. Yep, all right, cool. All right, were there any questions came up while you were taking a break on Excel or VBA? Any questions people have about this? All right, sounds good. It's a long close. So like I said, in these slides that Morgan's going to pass along to you, I put all kinds of information in here for you to study through and try out. So for example, remember I mentioned the VLOOKUP. So the VLOOKUP, I explained in here, what each of the different inputs are, and there's other if then statements. Talk about that in here. I talk about filtering and sorting, and Chris mentioned the different charts. That's all in here as well. And then I do a whole thing on pivot tables in here for you, so you can reference it later. Okay. All right. Good. Okay, so VBA, I also explained in here how the Visual Basic Editor, which is, I showed you real quick, right? That developer tab and how it built the code. But this is going to help walk you through what the Visual Basic window is actually doing and how to record a macro. So it goes through a little bit slower for you as you're going through the slides. And once again, if you have questions as you're going through it, please shoot me an email and just ask, and I'll see what I can do. Okay. All right, so let's talk about SQL, because remember the order of operations here. We have our data living on the server. We need to get that data. How do we get that data? We use SQL language because that's what the server speaks. It speaks in SQL. And some servers are Linux, but for the most part, actuaries are gonna be working with SQL language servers. And so SQL is gonna be an important thing to understand. So let's actually take a minute before we even talk about SQL and talk about how the servers are organized, because this nomenclature is going to be very helpful for you when you're trying to pull the data, particularly when you are talking to someone in IT or someone who is keeping track of the data. This is how they think. And so it's going to be really difficult if you don't know what they're talking about. Okay. So you can think of server. I'm going to use a metaphor here to kind of help you visualize it. You can think of a server as a room. Let's pretend it's the room you're in. And within that room, you have several filing cabinets. Okay. These filing cabinets, if you are a OCD and suave person, like I'm sure everyone here is, very organized, each filing cabinet is going to have a particular, thing. Like maybe this red filing cabinet holds all of the premiums, and this orange filing cabinet holds all of the expenses, and the gray one is all about claims. Okay. Well, or maybe it's different lines of business. This is workers' compensation, this is homeowners, and this is, this is small business. Okay, small business BOP policies. Well, those are similar to what are called databases. Okay, databases. So within a server, you're going to have numerous databases. And most of the time you need, for permission purposes, you need specific permission to look at each database separately. Just like these filing cabinets, all the stuff inside are separate from each of the other filing cabinets. The different databases on a server are going to be separate from each other. Okay. Within each database, you have what are called schemas. And schemas are going to be kind of like the drawers in this filing cabinet. So within this database that I have permission to, I can now look at all the different schemas, and maybe, remember, this was the premium database. So maybe this is going to have premium from workers' compensation, and this is premium from reserving needs, and this is premium for auto, and this is premium for homeowners. Okay, so the data is going to be organized within this database according to schemas. Okay, so that's kind of the nomenclature you want to use when you're grabbing the data. You want to understand which database you need to be in on which server and which schema you're going to be grabbing your data from. Okay. SQL, the way the SQL language works, and again, you're not going to get this from our conversation. I'm just introducing it to you. I would suggest doing the free sections of the Codecademy SQL, intro to SQL, just so you can kind of see it. But what I want to talk through is how the computer is thinking when you're using SQL language. And this is something Codecademy does not talk about. You'll come back to this slide later, and hopefully you'll remember what we talked about, or you'll look at the recording. But the way SQL language works is you have certain sections. You have a select statement, and there's a whole bunch of code that's in between here. A select statement where you're deciding on which of the different columns from your data set you want. The from statement is going to be saying where you want your data to come from. You're going to be joining tables on that. And then the where statement is going to be like a filter. Okay. All these other pieces we won't talk about today, but the select tells you which columns, the from is which tables you're using, join is if you need to squeeze more than one table together, and where is going to be your filter. So I want you to think about what you're doing with your SQL code. You're getting the data, aren't you? Okay. The power in SQL language is to be able to take this enormous data set that's in your database within your server and squish it down and filter it down into just what you need, right, for your analysis. So I'm going to take it, I'm going to squish it down, I'm going to filter it down to just what I need, and then I'm going to take that out of the server and put it into R or Python to do my analysis. Okay, that's the power of SQL, is to be able to filter it all down to just what I need. And the way the computer's thinking through it is it's going to look at the from statement first, then it's going to filter, then it's going to do some other stuff, but then it starts looking at the different variables. Now I'm going to, for the sake of the recording, explain this to you. It's not going to make sense now if you've never worked with SQL, but it will later after you go through the Codecademy. So my suggestion is to go through Codecademy, the free sections, then come back to this part in the recording and listen to me explain this. Is that fair? Okay, so future you, here's an explanation. I feel like I'm in Back to the Future. It's very fancy. Okay, so future you, here's an explanation of how the computer is thinking. Let's say I'm going to the library and I want to write a research paper. Well, I'm going to find a table and sit down at that table. Then I'm going to say, you know what? I need certain books. So I'm going to go to the shelf and I'm going to pick out the different books for my research paper. That's like what the from statement is doing. The from statement is saying, hey, database, I need this table, this table, this table, and this table. Okay. Then I want you to squish them all into one big table, sort of, right? So that I can work with. And that's what the join statements are doing. Now you notice that the computer is doing that first. It's going to grab the from and the join statements. I'm going to build this source for you first. Okay, so I'm writing my research paper. I went to my table and I have all of my books that I need. But the thing is, I don't need everything. I'm not going to read all 5 books. That's ridiculous. I don't have time to do that. So I'm going to go to the table of contents. I'm going to choose chapter 3 of this one, a different section of the next one, chapter 5 and 6 of this one, right? I'm going to filter my books down to just the sections I need for my research paper. And that's what the where statement is doing, which is why it's number 2. The where statement is going to filter this big old, set of source data down to just what I need, okay? The group by statement, future you, is going to say, do I need to aggregate anything by using a sum function or a count function or something like that? Yes, how am I going to do that? Oh, I want to do it by state, or I want to do it by, policyholder number or something like that. So the group by statement is going to allow me to know how to do that. Having is going to be a window function. We won't even talk about that. Then I can start picking out the different pieces that I need for my research paper. Then I decide which columns I want. Then I decide which summations I want in my output, okay? And that's why this is number 5 and number 6. Distinct means I don't want any repeated rows. I want it all to be distinct. It takes away duplicates in your data. Okay. Then I've written my research paper. It's all ready to go. I have everything I need. I've got all my quotes from books. I got everything I need in there. And the last thing I need to do is edit it. I just need to do one last edit. And that's what the order by statement is and why it's last. Okay. The order by statement might be, okay, I have my final table. I got this output, but before I give it to you, user, I am going to alphabetize it, or I'm going to organize it according to state, or I'm going to, organize it according to premium dollars. Okay. And that's why the order by statement is last. So it's just like building that research paper. It's logical, right? I go from biggest to smallest, and then I export that. It saves space on, in R when I'm doing it. And so again, from and join are the first thing that happens. Filter it down with the where statement. Tell the computer what you're going to do with the group by and having statements, then do it. Your select distinct statements, and then finally any final touches that you want to do before you export it. Okay. Any questions on that? I'm just kidding. This is a recording feature. You can't ask questions right now. I won't be able to hear you. So, but if you do have questions at that time, you can email me, right? So SQL, and then I put some information in here to help you with joining and join tables and some example code and example of what's going on. This again will help you more after you do the Codecademy free sections, but let's help you understand what the different joins are. Okay. Any questions on SQL? All right, so we've got our data from the databases. We got it from the server. We've filtered it down to just what we need. If it's small enough, we put it in Excel. We do our analysis. If it's medium, we might put it in Access and do our analysis. If it's big, we're going to put it in R or Python. Okay. So in R or Python, this is what R looks like. Okay. Super scary at first, isn't it? Look at all that weird, scary computer code. Super scary looking, but it's really not. It's just, you just need to learn a new language. You just need to learn a new way of doing things. And so the way R is organized is, let's go ahead and put a file in here. The way R is organized is it is a language. R is the language that we're using in here. R Studio is going to be the app, right? It's the app that you're going to use when you're trying to massage the data using R. R Studio is free. Wait, what? Yes, it's free. So you can actually, in fact, in the slides, and Morgan, did I send you this HTML file? I think I did, right? I didn't just send you the PowerPoint. I sent the HTML file as well.
Yes, you did.
Okay, yeah, so Morgan will send this to you as well. Within here, this HTML file, which I actually built in R. This isn't, R can build slides too. It can do all kinds of cool stuff, okay? This is how you get R on your computer. So if you want to get R Studio on your computer and start playing around with it, this is how you do it, okay? So I put that in there for you. I put a tour how to walk around R Studio once you have it on your computer, how to set it up, basically everything, all the basics of getting started in R, put in this HTML file for you. Okay. So what do we use R for? Well, let me walk you around R Studio here for a second, so you can understand kind of how it works. Down here in the bottom right, called the file pane, you probably recognize something like this, right? It's just like Windows Explorer, where you're looking around your laptop for certain files, and that's exactly what's going on here. So if I want to, let's say I want to go to, I can look around the different files that are on this server, or in your case, it would be on your laptop. Okay. So you can access the different things. For example, I can go to my desktop if I wanted to, things like that. Okay. And so if I, yeah, there's all kinds of different stuff in here. So, but up here in the top left is where you write your code. This is the code that you want to save. Okay. This is the type of code that you want to save. In the console over here, it shows you what the computer is thinking. That's really helpful for troubleshooting. And then down here, for those of you that have coded before, the environment is going to show you what you have, what variables you have available to use while you're coding. So for example, if I designate a variable X as 45, okay, you see how it shows up in my environment, X is now 45. So if I then also designate Y as 20, now I see that Y is 20. And so if I wrote some code that was, X plus Y, it's going to give me 65. See that? Okay. And so that's, that's kind of how it all works. If I want to save that code, I could do the exact same thing here. X is 45, Y is 20. And now it's been saved. I could also run it and the computer will run it for me. I can then be like X plus Y. If I run it, it ends up running the code as well. Okay, so let's say I make Z is now X plus Y. Oh, look, Z showed up as 65. Isn't that neat? Right. Obviously, R does way more stuff than this, but R is going to be just another language that you're going to learn. The reason why R is so helpful, again, is because of the different stuff that you can do with it as an actuary. It is so versatile. And in fact, like I said, I made these slides in R. I can build what are called shiny applications in R. Let me show you an example of that. I'm trying to think of the things that I'm allowed to show you. Yeah, hold on. Let me get there. First of all, well, while I'm doing this, does anyone have any questions? Everything I explained made perfect sense because I don't believe that. Does anyone have any questions? Or is it just kind of new and overwhelming? Yeah, let me show you this is pretty cool actually. Let me show you what a shiny application looks like. So this is an app that you actually build in R. So let me show you. Here's the R code. Okay, pretty neat stuff. And what that R code does is it builds an app. Okay, so here's an app with drop downs and it can run different things. You can put iterations in here and you can run it, and then you can export an Excel file. So all kind of, you can see how this can replace a lot of what you're handing over to your business partners with an Excel file, right? Now the business partners have an interactive application that they can change different drop downs, and the exhibits will change, and then you'll have, so R has the endless possibilities when it comes to different things you can do with R. And remember earlier, I showed you, or I told you that you can do pulling directly from the server in your R code. And that is exactly what this code is actually doing. Right here, it says pull Oracle data. Oracle is the type of server. And you can see that it is referencing my SQL code. Look at that, select statement, a from statement, a where statement, just like we were talking about. So it is using the R language to then reference a file that has SQL language in it. And then R in this particular code is doing this. It's saying, hey, I'm on either on a laptop or on a server, and I'm going to log into the Oracle server. I'm going to run the SQL code in the Oracle server, grab that output data that I want, bring it back into my environment, and now chug through and do a whole bunch of other stuff in this application. Pretty cool stuff, right? Okay. Feels a bit overwhelming, but you can definitely learn this. You can definitely learn it. If I, a public school graduate from Florida, Northern Florida, could learn this, you can learn it. Absolutely. No offense if any of you went to public school in Northern Florida. Chris, were you going to say something?
Just that Top Brass loves R. If they, prospecting for new employees, if you have that skill, it's a big plus.
Yep. R is definitely where things are going from an actuarial standpoint in particular. So again, like I said, I would know how to, I mean, we have 5 minutes left, so I kind of conclude, right? Again, I made these slides. There's so much on these slides. That's more for you later than it is now. But so let me go back to this slide here. Because what I kind of want to conclude with, and I do want to leave some time for additional questions, but what I do want to conclude with is, what do you walk away from this conversation with? What I would suggest walking away from this conversation with is a high level understanding of how actuaries use data to do their job. And the second main thing is what you need to focus on as far as like learning new things to help your resume. Okay. And so I would suggest really knowing Excel, particularly VLOOKUP and pivot tables. I would suggest having an introductory understanding of SQL. And then if you're going to spend your time digging into any language, just like Chris mentioned, it would be R. I would spend the time learning R. If you already know Python, that's great. That's awesome. But if you're going to spend some time learning another language, I would learn R, which is really easy because it's crowdsourced and it's free, right? You can use the slides that Morgan's going to send you to get R Studio on your laptop or on your computer, and then just start playing around with it. In that first download, there's even data sets in there that are already built in that you can start playing around with. Okay, it's good stuff. So Samuel says, what's the benefits of using R Markdown instead of the normal script? Oh, very, very good question. R Markdown is just so cool, right? Because you can have code and exhibits and all kinds of really neat stuff with R Markdown. In fact, let me show you an example of an R Markdown here. Here's an R Markdown. I don't know why this is taking so long. That's weird. So this is an R Markdown. It's got a table of contents. You can have all kinds of links in here. You can have exhibits. You can do all kinds of, looks like a web page, right? It's pretty neat. And you can send it, you know, for example, if I want an R Markdown with exhibits and all kinds of really cool results, and it's interactive, I can send a link, a browser link to my business partners instead of, you know, a file in an email. I can just send them the link and they can play around with it. Same thing with the Shiny applications, the slides, everything, you know, it's all built into HTML if that's what you want to do. So does that make sense, Samuel? Thumbs up. All right. Very, very cool. All right. Cool. Any other questions on really anything we talked about today or anything in general? What other questions do folks have? All right, Morgan, pass the time over to you. I'll stick around if people have questions. Okay.
Yeah, definitely. I'll just end the recording, and if you all want to stick around and ask Dan a few extra questions, then you can definitely do that. Thank you, Dan, so much for this. This was really amazing. I feel like this was very interactive. It was very refreshing, especially on my end as well, to see. And you said you were a math teacher, correct? Are you taught or something like that?
Yeah, I actually, yeah, I'm a professor at UConn. Yep.
Yeah, I can tell. Yeah, you.
Oh, really?
Yeah,
Thank you.
can definitely tell. Yes.
I'll take that as a compliment. Thank
No,
you.
it's definitely like you can tell you're an educator. So I definitely think that this was very insightful and just like I said, refreshing overall.
Thank you.
And I know that they got a chance. Yeah, thank you, Dan and Morgan. Yeah, I love the fact that I'm able to bring you all these different people that have all these different backgrounds and able to connect and network with you all. This is really amazing. And one of the main reasons why I wanted to start working at IABA. So this was just great. I know that there are a couple of hands raised.
Morgan, thank you for putting this together. Seriously, thank you very much.
Thank you. Thank you.
So Lizzie Tolan asked the question, is how many exams should one take to choose between SOA and CAS? That is a really good question. It's getting tighter and tighter, but you know, P and FM, obviously, right? Those are still between the two. After that point, you almost need to either choose, or you can always switch, to be honest. In fact, at the Hartford, even though we're PNC based, we have quite a handful of FSAs. So, you know, having a fellowship just doesn't necessarily tie you into life and health. If you're an FSA, or if you're an FCAS, tie you into PNC, it helps, but you can always switch around. That's fine. Hopefully that made sense. Let's see, Carl, do you have a question?
Yes, I do. I really develop an interest in languages, but I felt lazy because of not having the resources and not having maybe like not having, like, maybe going to the internet and start studying from there. Like I've really been lazy, and I wish to know if your note, your slide, your introductory. I saw you get some introductory notes to R and SQL and everything. I really know, like, the way I saw the way you like the way you presented, demonstrated your application, the code, the coding line, how you like. I saw they were really many. I know they are fascinating. They will, and I really want to know if those notes can, if someone, like for me, I'm like a beginner. If like, can I really start coding like you, like the way you did, for example, with those notes? Like if I like really understand, or do I need to go deeper?
No, I mean,
Like,
as with any language, you know, because that's really, coding is just learning another language, right? So as with any language, you're going to have to start slow, and then you'll get better, and then you'll get better, and then you'll get better as you practice. So
okay,
I would start with Codecademy for SQL. And then I would start you know, there's lots of free stuff online, to be honest, with R and even Excel.
Okay.
So, and then just practice, just like with any other language. Just got to practice a bunch. Good question.
Okay.
Chris.
Oh, just a quick comment from Miss Morgan and IABA regarding you as a speaker today. I've gone to so many of these over summers, sometimes required by employers, but I think you've done a great job bridging the gap between the profession and then, as Miss Morgan said, as an educator, to where anyone here, I think, can really gain so much from this talk. So thanks so much.
Yeah, no problem. Thank you. I appreciate that. So there's 3 people on the call, four people. Oh, there's a few people that joined a little bit later. Oh, wow. There's quite a bit that joined a bit later, right?
Yeah.
Yeah, again, for the people that join later, feel free to reach out to me if you have any questions, or if you want to kind of meet one-on-one about something. Okay. That goes for everybody.
Yes, everybody. I always try to encourage everybody to connect with these actuaries that are making their time available to you all, and really trying to connect. And, you know, like Dan said, they are now successful actuaries, or they're really in a good spot. And this is a way that they use their time, they give back. So definitely try and reach out. Well, you don't have to try, they're here. So just reach out. Yes, definitely. These are some of the resources I wish that I had when I was in college. So definitely take advantage of all of IABA resources. So we're going to go ahead and wrap it up. And as you all know, I'm going to be sending out emails later this week, probably tomorrow or early Friday. And the YouTube video should be uploaded as well by tomorrow. So if you all have any questions, be looking out for that email. And thank you for answering my question. Yep. It was such a great session. I really enjoyed myself as well. So yes, if you all need anything from me, reach out at m.colvin@blackactuaries.com. In fact, I'll drop it in the chat very quickly. But yes, just contact me. I will be sending out an email, so you can just respond to that email as well. I'll include Dan's information, the PowerPoint, the next session information, which our next session will be May 18th, which will be going over personal branding.
Right. Oh, and the HTML file for R as well.
Yes, yep.
Thank you.
Yeah,
Appreciate that.
Thank you so much. And
Yeah, no
I
problem.
hope that you all have a great rest of your evening. Stay safe. It's getting warmer outside. COVID is real. So please stay safe and take care.
Thanks, y'all.
Thank you. And if you have any questions, remember Dan said he will stay a little bit.
Yep.
So yeah, I'll just end this recording.